In this lesson, we'll be talking about check sheets, diagrams, and charts used in quality control. The learning outcomes I want you to get out of this lesson are to be able to construct and employ the following tools when given a quality control problem. These tools are the Pareto diagram, the cause and effect diagram, process flow diagrams, check sheets, histograms, and control charts. This is going to be a real simple lesson. A lot of these concepts are real straightforward. You may be familiar with some of them already, but we just have to go through them because we'll be using them later on in the semester, especially as we introduce you to statistical process control. We'll be using some of these tools when we get to that point. Let's start with Pareto charts. These have been around for quite a while. They were invented by a guy with a great name, Alfredo Pareto, in 1848. He was interested in characterizing the spread of wealth in Europe. He had a hunch that there were a few people that were very wealthy as compared to the rest of the population that didn't come close to the amount of wealth that they had. You might think of the elite 1% that's talked about in the U.S. We talk about taxing those elite 1% so that the rest of us can benefit from them. How would you characterize the elite 1% as compared to the rest of the population? So here we can start out with an example in foods. Think about oatmeal cookies. The way this works is you rank data classifications in descending order from left to right. So the classification in this case are quality problems encountered in oatmeal raisin cookie production. You might think of your own kitchen, the times that you've made cookies. Or maybe growing up your mom made cookies that were excellent, but maybe your mom also made cookies that were also not excellent sometimes. Maybe there were some that had, some of the batches that were put in the oven had some characteristics that were not ideal. So there are three concepts to keep in mind in this chart. The first is the concept of the vital few. Here you can see that the vital few categories are those that dominate the ranking. In this case, it's the burnt cookies and the cookies with the too few raisins. Those clearly rise above the rest. Next, we can talk about the useful many. These are those that don't come close to the vital few in terms of frequency, but you can see if you started stacking them up, they sure would add up. So we can focus on cookies that have bad off flavors, or maybe the texture's not right because they're too hard or too soft, or maybe there were too many raisins on these ones. The last thing to keep in mind is that you can come up with characteristics that maybe when you add them up in terms of the frequency, they don't come close to these other problems like the burnt cookies or even the characteristics with the useful many. But when you add a bunch of these characteristics of the smaller ones up, they do compare. So in the practice of putting these Pareto charts together, it's common to put the other category on the far right. One thing that's useful to do with these Pareto charts is to apply a cumulative frequency operation on them. It's a simple process of just seeing how all of these bad quality characteristic defects add up. So we start out with the vital few, the first one that had the most frequency of defects, and those are the burnt cookies in this case. Then we pretty much just stack each of these other characteristics on top of the first one. So here we have a 42% frequency approximately of the burnt cookies. So the next step is to add the cookies with the too few raisins. It's about 31% there. So we would just stack this one on top of this one, and that's how we get somewhere between 70 and 75% frequency of those first two defects. Then we just keep doing that, so on and so on and so on. And what you end up with is a cumulative frequency of 100% by the time you get to the right side of that chart. So creating a Pareto chart is a pretty simple and straightforward process. And we could illustrate an example of what this might look like in the candy industry. Suppose you're working for a candy company and you're making these caramel-filled chocolate products, and you can identify several quality problems that are just very obvious. Some of them have a grainy caramel texture. In other ones, the caramel's too hard. Sometimes the caramel inclusion is off-center inside the chocolate. Some of them just have horrible off flavors, or the color is just way off, and you can count the number of candies with each of these problems. With this data, you should be able to identify what are the vital few, what are the useful many. You should be able to create a Pareto chart that would illustrate each of these defects. And you should be able to include a cumulative frequency line on that chart. Here's what that chart should look like. Next, we have the cause and effect diagram. This was developed by Karo Ishikawa in 1943. It's helpful to remember this because sometimes you might hear the cause and effect diagram referred to as the Ishikawa diagram. These diagrams are useful because you can evaluate the causes that lead to effects and determine whether they lead to positive effects or negative effects. It's just a matter of simply identifying an effect. Some sort of quality characteristic would be the effect, and then you just identify the causes that lead to that effect. This is one type of cause and effect diagram where there are 4 steps that lead to the development of that product, and with each step there can be major and minor causes that would lead to some sort of effect. Here's a real general example of what one of these cause and effect diagrams might look like in the bioprocessing industry. This could be a process for brewing beer. And we start out with the first step, which is mixing all of the ingredients. And the major causes that might lead to any sort of effect in this case could be the time of mixing or the speed of mixing. Or maybe a minor cause could be the agitation during mixing. The next step would be the fermentation step. Again, the time might be a major cause that would lead to any sort of defect. Maybe tank setup would be a major cause that would lead to some sort of defect. Might depend on who's doing it and how they were trained. Maybe some minor causes that might lead to an effect in this step could be the temperature of fermentation or the yeast health. And so you could evaluate whether these are major or minor causes that could lead to an effect. You might disagree. You might say that the yeast health would lead to that the yeast health could be a major cause that would lead to an effect. And so on. That's what we do. We have 5 steps that might lead to any sort of defect. There are actually 3 different ways of coming up with the cause and effect diagram. So far I've just shown you the first way, the first type of cause and effect diagram, and that type is the process analysis, where we have different steps in a process that lead to the final product, and for each step in that process we identify major and minor causes that might lead to some sort of an effect. The other 2 types of cause and effect diagrams are essentially the same once they're complete, but the way of going about them is totally different. We don't consider any sort of steps in the process. Here you can see these boxes that were up here are not in these types of cause and effect diagrams. We just identify any sort of major or minor cause that might lead to an effect. And so one of these could be training, for example. Maybe personnel issues is the major cause for some sort of an effect. Maybe the training is not bad, maybe the morale is not bad. Maybe there are other issues that have to do with the people involved in this process, so that could be a major cause, and we could identify a bunch of minor causes that might have to do with that. The reason the cause enumeration and the dispersion analysis type of cause and effect are different is just that the approach is different. In the cause and enumeration method, we just come up with a shotgun approach. We get a bunch of people together, or it could be just you, but you just brainstorm as many causes that might lead to an effect as possible. And then later you sort those out on paper and evaluate whether they're major causes or minor causes. And you can group them together accordingly. The dispersion analysis type of cause and effect approach to coming up with the diagram would be just looking at these one by one. You might just start out by talking about the people in the process. Then you could identify what is the major cause for that, what would be the best heading for that major cause. Maybe it's training, and then maybe the minor causes are bad training, or maybe employee morale. It would just depend on the setting. So let me ask you, how would you go about creating a cause and effect diagram? Take a minute to think about it. What would be your first step? What would be your second step? When would you know you were done? Typically, the first step is to come up with some sort of effect. Identify and define what the effect is that you're interested in. Otherwise, it wouldn't make sense to come up with the causes. And so the second step would be to brainstorm possible causes that lead to that effect. Then finally, you would construct that diagram, and this is where you're really evaluating what are the most likely causes. That will help you to distinguish what are the major causes and what are the minor causes. And of course, the last step would be to pursue corrective actions. Let me ask you a question. How would this process change depending on the type of cause and effect diagram? In other words, I already gave you a hint in terms of the cause enumeration versus dispersion analysis type of cause and effect diagram. But would this process be different? Would these 5 steps be different if you were making a process analysis diagram as opposed to one of these other 2 types of processes? It probably would change, right? A process analysis cause and effect diagram would probably be much easier because it's just a matter of identifying the flow or the steps involved in that process. Going back to the example of brewing beer that we just talked about, it would be easy to start out with what's the first step in that process. In that case, it was mixing the ingredients. Then you can distinguish major and minor causes involved in mixing the ingredients. And then you would just do so on with the next steps in that process. So what can we use these cause and effect diagrams for? I can think of about 4 things that would be very useful. The first one would just be analyzing process conditions for improvement. We would analyze them to distinguish what are the bad causes and what are the good causes. Then take this a step further and eliminate the conditions causing the quality problems. So we would just take all of those bad causes that are leading to bad effects and we would just get rid of them. Then we could take this a step further and use it to standardize processes. Say you're working in one particular processing plant and you've created a cause and effect diagram, you've analyzed it, you've gotten rid of all of the bad causes that are leading to bad effects. You can just take that to another processing plant that makes a similar product or maybe the same product and implement this cause and effect diagram there to make sure that you're not having the same bad causes that you did before at the other processing plant. Then you could take this a step further and just use this cause and effect diagram for decision making and corrective actions training. You could get in a training session and show the employees what are the things that are leading to the effects in the final product. Next, we'll move on to probably the easiest concept that we'll talk about in this lesson, and that is the concept of creating a check sheet. These are simply used to ensure that data collection is quick and accurate. The data in one of these check sheets should be in a form. Here you can see a form on the right where it looks like the typist, Kelly Hall, was examined by Jay Brown, and there are these types of errors that were decided on. One could be reverse letters, missing letters, extra letters in their typing, or the wrong letters in their typing. And we have the date here, so we have important information. We have the test number, and we can use that later on when we enter in data in a spreadsheet. And we just simply count the number of times that this particular problem happened. Then we can add those up and summate them to a total number of defects. So these check sheets could be used for a number of things. Here's just one example. It's not food related, but check sheets are used all the time in the food industry. Question to think about, some of you might know, but is there an app for this? When I worked in industry, it was a nightmare to keep track of these check sheets. I would be working on the graveyard shift and I would have a clipboard with all of my check sheets, and then I would put them in a file, and then someone else would enter they would get that check sheet from the file and then enter it in a spreadsheet. And sometimes there would be error in that process of entering in that data into the spreadsheet. But I think this is the way the industry is headed, is getting apps or some sort of electronic or digital or wireless way of entering in the data from the check sheets. The next diagram we'll show here is the process flow diagram. I'm sure you've seen this before. It's a simple process of showing how the inputs go into particular steps, and we have processes between the steps, and then it all leads out to some sort of output. And the outputs can be byproducts or actual products or waste. Another diagram is the histogram. In this case, we put some sort of data characteristic such as weight on the x-axis, and then put the frequency of those data on the y-axis, and we get some sort of distribution. And we can identify and define what is the optimal data point in this, and then we can characterize what is the process capable of. That's the data that is within this frame, and then we can identify some sort of tolerance. I know this is a very brief definition of histograms. We'll identify and characterize histograms in much more detail later in the semester. The last type of chart I'll introduce today, we'll talk about this in much more detail later on in the semester, is the control chart. Here we have some sort of subgroup. This could be time, it could be the number of batch, and then we have on the y-axis some sort of data characteristic. In this case it says subgroup average, but this could, in the simplest case, just be weight of that product. Maybe it's packages that are being weighed, and it's the weight of those packages in grams. And so we have an average here. That's what this black line is. We have the mean of that data for this particular set of data. And we'll talk later on in the semester of the formula used to identify the upper critical limits and the lower critical limits. These limits are used to identify when are we in trouble and when are we not in trouble. In other words, if we're above this critical limit, then we're giving away excess product and we're losing money that would otherwise be benefited from. Or if we're below this limit, if we're going off of the weight example, then we would get in trouble for false labeling. If we say that we're selling 1 pound of product and we're not meeting that, then it's an easy way of identifying when we're in trouble. This concludes this lesson. In summary, we talked about how Pareto diagrams are used to identify categories with the largest frequency of quality characteristics. We talked about how cause and effect diagrams are used to determine what contributes to quality problems. We showed how check sheets aid in data collection and analysis. We talked about how process flow diagrams allow us to examine an entire process. We showed how histograms illustrate variability in processes, and how control charts are useful in pinpointing good and bad treatment effects.